Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by AWS and Snyk. My name is Cody, and welcome back to Techstrong Learning. We've got an action-packed couple hours, hour and a half, 2 hours here, depending on how long it takes. And we're so excited to get this kicked off. So thank you for joining us today. A couple of notes before we get started. Today's session will be recorded. So if you happen to miss any of our workshop, if you'd like to watch again or follow along at a later time, or of course, if you'd like to share this with the rest of your team, you will be receiving the recording via email shortly after we conclude this live session today. If you'd like to get engaged with us here, there are a couple of ways to do so. The first option is to use the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you are joining us from today. I'm seeing Bulgaria, Brazil, and Baltimore, Maryland. So awesome. Thank you for everyone for coming all around the world. If you have any specific questions, we do want you to direct those to the Q&A tab on the right side of that chat section. Submitting your questions to the Q&A just helps us keep organized when answering your questions. And we want to do our best to answer as many of your questions as we can today. So just be sure to send them to that Q&A section. And finally, we will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. And you can become eligible for that giveaway by sending in chats, sending in questions, and of course, filling out our post-webinar survey. So our topic today is AWS Immersion Day, securing your infrastructure as code with Snyk and HashiCorp. I'm joined today by David Schott, Staff Partner Solutions Engineer at Snyk. We have Shivam Jindal, Partner Solutions Engineer at Snyk. We're also joined by Raj Jerry-Pachula, Senior Partner Solutions Architect at AWS. We have Patrick Vassell, Solutions Architect at AWS. And last but certainly not least, we have Yash Kamani, Solutions Engineer at HashiCorp. So thank you so much to everyone on this panel for joining us today. Raj, do you want to go ahead and take us into our presentation?
Thanks a lot, Cody. Hello, everyone. Welcome to Securing Your Infrastructure as Code with HashiCorp, Snyk, and AWS. My name is Shashiraj Jeripotula. I am a Senior Partner Solutions Architect at AWS, and I work mainly with ISVs, independent software vendors, and AWS partners specializing in cloud ops and DevOps segments to develop joint solutions and accelerate cloud adoption on AWS. So today, I have a great set of panel members who will be sharing their expertise on Snyk, HashiCorp, and AWS. So let me introduce you to the speakers. First, at AWS, I have Patrick Vassell. Patrick?
Hi, guys. I'm Patrick Vassell. I'm very excited for the event today. And essentially what I do at AWS is assist partners with, finding the art of the possible. So I'm very excited about today's session. I hope you guys enjoy it.
Thanks a lot, Patrick. So let's get back to Snyk. David?
Yeah, hi, everybody. I'm David Schott, and I am feeling the holiday spirit. I hope you are too. But in all seriousness, I'm a partner solutions architect at Snyk. I've been at Snyk for about 2 years now. I work with AWS, who's a strategic partner of ours, on things like new integrations and go-to-market activities like this webinar. And very excited to be here today. I'm going to disappear for a little while, but I'll come back when we kick off the webinar portion.
Thanks a lot, David. Shivam?
Everyone, I'm Shivam, Partner Solution Architect here at Snyk. I work with a lot of our strategic tech partnerships as well, covering folks like Atlassian, Slack, HashiCorp, and a handful of others on what better together stories could look like for our joint customers and as well as potential integrations. So excited to be here and talk a little bit about what we have with Hashi.
Thanks a lot, Shivam. Finally, from HashiCorp, Yash.
Yeah, thank you so much. I'm Yash. I'm a solutions engineer at HashiCorp. I also play Santa this time of year. Been with HashiCorp for a little over 5 years and work with our customers here in the Mid-Atlantic.
Thanks a lot, Yash. Let's get started. So the plan today is you'll get free access to AWS to do the labs. Then you get free access to Snyk, HashiCorp. So we'll go through all those instructions. You'll also get to hear some of the best practices and expertise from Snyk and HashiCorp on what we are going to do in this webinar. So there's a lot to learn today. So let's get started. So let's get started with the AWS workshop setup. Here, Patrick will talk to you about how to get access for free for AWS. I think you'll have up to 24 to 48 hours to go and learn something new in AWS. So Patrick, handing over to you.
Thank you, Raj. So as Raj mentioned, we are giving you all access to free AWS workshops, and I'll be assisting you on setting that up. I actually just sent a link in the chat, and if you guys can click that for me, it will direct you to getting access. You just have to sign some, just to confirm your account, and I'll show you how to register there really quick. But just a quick synopsis of you just want to make sure that you're frugal. These are these are our AWS accounts and on our infrastructure. So these are not free for us, but we do want to make sure that you guys get the optimal experience and being able to test and experiment and follow along in the entire session that we have today. And I see that there's a question about, can we do this lab tomorrow? Yes, I'm actually going to give you an extension to 72 hours to access this. So if you aren't able to access this today and run through the lab, you can go ahead and do it at your own leisure. And it's going to be good for 72 hours from now. So I'm actually going to share my screen and show you all the process. So just make sure you can set up your accounts here. Yeah, that's right, Cody. But yeah, let me go ahead and do a quick screen share for you all here. And yeah, just make sure you click on that link that I sent in the chat there. And this is what should show up upon clicking that here. My pleasure, everyone. All right, cool. Let's let it load up here. All right, awesome. So the best recommendation would be to set up with the email one-time password. Sometimes it can take a minute or two for you to receive it, but just go ahead and click it, and it will give you, that link, and you should be able to go ahead and sign in. Since I'm an employee, it's a little bit easier for me just to sign in here. All right, 1 second. I'm not sure if it will register with my YubiKey from the session. I guess it's not registering because I am using like a third-party site there. But nonetheless, what you'll do is once you sign in and register, there's going to be a section here, and you will be able to. I wouldn't recommend using your regular account because these can cost. But since we have the accounts provisioned for you, just go ahead and use it. Once you sign in and register, there's going to be an option on the bottom left where you can click Open AWS Console. Once you're in the console, you'll be able to go ahead and experiment and follow along with the team here, and you'll be able to go ahead and access. So I guess I do apologize about the two-factor not working on my side, but nonetheless. This is pretty much all you need. And if you have any issues or questions with getting access, please let me know. I'll go ahead and assist you on in the chat side there. But that's all for me, and I hope you guys really enjoy the session.
Thanks a lot, Patrick. So I and Patrick from AWS will be online. So if you have any issues on how to use the tool or how to navigate in the tool, we will be there to assist you for the next 2 hours. And usually for this kind of webinars, immersion days, we usually give 24 hours free access to AWS. But Patrick has been very generous this time, so he's given 72 hours. Just imagine what you can learn in 72 hours. So you'll have like free AWS account to go and learn something new, which you always wanted to learn, but you didn't do it. So use this 72 hours to learn something new and also get a chance to learn Snyk and HashiCorp today. So with this, I will hand it over to Shivam to go through the presentation followed by labs. Shivam, all yours.
Awesome. Hello, everyone. I'll go ahead and just jump into talking a little bit about Snyk. As you can see, our kind of motto is develop fast and stay secure. And really what this means is Snyk is all about being a developer security platform. So we have 4 products in particular. We have Snyk Code, which scans first-party code that developers are writing. Snyk Open Source, looking at third-party dependencies or libraries, even transited dependencies that they may be using, providing things such as auto-fix remediation advice and helping prioritize these vulnerabilities. Snyk Container, looking at the actual containers that developers and teams are building, and Snyk Infrastructure as Code, looking at things like Terraform to see how teams are actually deploying their cloud resources worldwide. And so we can scan these different aspects of an application, as well as work with a range of different industry partners as well, to provide additional insight. And that's really where the HashiCorp integration, of course, fits in as well, which I'll touch on in a little bit. Talking a bit further about the Snyk platform, like I said, we have these 4 scanners, which scan, again, first-party code, open source libraries, containers, and infrastructure as code. But it's more than just being able to scan these vulnerabilities. Of course, anybody can build a scanner. But really what makes Snyk kind of unique in this space is our developer experience. We are focused on helping work within the workflows and processes and tools that developers are using, and providing a seamless experience for them to help them understand what are the vulnerabilities, how to prioritize it, and how to remediate it within the workflows and processes that they're using, while also helping application security teams actually manage their application security programs. And so to kind of zoom out for a second here, it's important to recognize, that development has changed quite a lot. More teams are kind of producing code at a much faster pace. And obviously with AI, that is going to simply accelerate even further with things like Code Whisperer or ChatGPT, et cetera, where you can figure out, add in more code at a much greater scale. Along with that, the software supply chain has obviously become more complex with microservices and dependencies having their own dependencies and so on. And those can often go many layers deep, right? And so it's important to have that sort of larger view on what are all the different moving pieces there. And then finally, of course, the cloud is part of the code as well, right? How the cloud is configured, how your resources are configured, can often impact how you need to think about the applications that are built there, as well as any vulnerabilities that may be baked into your cloud applications. And traditional security really hasn't kept up with this process, right? Oftentimes, traditional security has been too late in the process. Very oftentimes it is audit-based. I've heard cases with customers where they are scanning their applications that are already in production once a quarter, right? And then generating a spreadsheet list of vulnerabilities to give off to their developers to fix a quarter after those vulnerabilities are already in production. And that's not really effective, because that means that you're leaving room for being exploited, right? And so some teams, some companies have started, thinking, we need to shift left. And oftentimes what that means is right before it makes it into production, right there, then we can add in some scanning. And it ends up being the spreadsheet list of vulnerabilities that doesn't really help anyone, right? It doesn't say, here's why you should focus on it. Here's how you should prioritize these 200 vulnerabilities. It's just, here are 2 vulnerabilities. And then there's no remediation as well. It's not really fix-based. And so then, some folks started building in IDE scanners. IDEs are often the text editors that developers are using. But a lot of times with a lot of IDE scanners, it is trimmed down rules, so not the same full rule set that is actually being scanned later on in the process. And so, you may be told you're good to go, and then later on in the process, you're told, actually, there were vulnerabilities that you need to resolve. And that can lead to surprises for developers and frustration for developers. And so traditional security really hasn't kept up to the challenge in being fast, in being accurate, in being prioritized. And that's really what we've seen a lot when it comes to developers and security, right? Developers and the development process is frustrated with too many tools spewing a lot of security data and not really knowing how to prioritize these different vulnerabilities. Meanwhile, security is focused on, let's block builds, let's manually triage and figure out how to stitch all of these various different tools together in some sort of way. And so this kind of captures a lot of the challenges that I mentioned, right? Traditional application security is often after the fact, is audit based, and things are done independently, right? They don't take into account that that a library is built into a container, that container is deployed into a cloud infrastructure, that cloud infrastructure has some additional configuration around it that may make it more susceptible or less susceptible to risk. Meanwhile, what we really want is a developer-first approach. When you can have developers scanning as early as possible with the full security suite and continuously with a fixed-based approach, a prioritized approach that takes that cloud context into account. You can, make developers or help developers focus on what actually matters, what will be the most impact, and help them build securely from the ground up. And that can often be very impactful for helping you build securely while continuously monitoring for any issues. And so this kind of captures just how Snyk can fit into that. Like I said before, we have these 4 different scanners, but we want to really bake ourselves within the workflows and processes and tools that developers are using, whether it's the text editors, whether it's the SCMs or VCS tools like GitHub, for example, that they're using, etc. And so we can scan as early as the text editors that developers are using, or we can even scan within the source code management tools, such as the GitHubs that they're using, and look at the different vulnerabilities there. And we can continue moving to the right as well. We can scan in the PRs that developers are using. So when they submit new code changes, we can look at, did that new code change introduce any issues? And then, of course, as far right as the container registries or the Kubernetes environments that developers are using as well. We can even bake ourselves, of course, within within Terraform Cloud as well. And within each of these processes, I think that bottom part where it says security education at the bottom is really important. We aren't focused on just a spreadsheet list of vulnerabilities. Of course, we're going to show you all the vulnerabilities, but we want to help your teams actually prioritize this and also learn how to actually fix these vulnerabilities and then actually remediate them. And so we have an entire security education platform as well for teams to understand the different vulnerabilities when they write them. So if you're writing, in JavaScript and you write an SQL injection vulnerability, we'll say, hey, here's an SQL injection vulnerability. Here's why it matters. Here's how to prioritize it. And here's a link out to the Snyk Learn site, so you can actually learn what is this type of vulnerability. You can try to exploit it yourself in our playground and a lot more. So a lot of details for people who want to go that far, right? And this kind of shows you to the point of prioritization as well, right? We can bake ourselves in to any step of the process, whether it's the IDEs, the repos, the CI/CD process, but we can also take that cloud context back into account to prioritize risk within the issues and vulnerabilities that we find as well. And so really all of this is focused on taking, the problems of yesterday of manually stitching many tools together, manually triaging and prioritizing and managing all of these tickets to actually helping empower developers in the process, to helping create some sort of automated triage and prioritization as well and help you actually manage your application security programs. While also being able to govern through visibility, automation, and policy guardrails. And so that's what the Snyk Developer Security Platform is really all about. Again, it's about working in a way that helps developers and security both build securely, continuously monitor, and manage the application security programs. With that, we're going to jump into learning a bit about HashiCorp as well as Terraform Cloud and a bit about our integration together. Yash, do you want to kick it off from here?
Sorry about that. Hopefully you can hear me okay. Let me get my screen share going. 1 second.
Yep, and we can hear you all right.
Excellent. All right, so just want to provide a quick overview of how you can use Terraform Cloud, which is our infrastructure as code platform, and Snyk together. I'll provide a quick overview of Terraform for those who may be unfamiliar, and then we'll talk about the integration, and what I'm about to describe here, you'll actually get to do hands-on in the workshop today. So, we come from various traditions, whether it's working with, traditional data center infrastructure or working in the cloud through a UI. And a little while back, it became apparent that in order for us to be able to really leverage the power of the cloud, to be able to do it at scale, that there is value in codifying our infrastructure, right? So the concept of infrastructure as code is that you describe in a declarative manner what it is that infrastructure should look like. In the case of Terraform, we do this using the HashiCorp configuration language, or HCL, right? And when you're working with Terraform, it's not unlike working with really any other code base, right? When we want to collaborate on something, we work with some sort of a version control system. So this could be, your GitHub, GitLab, Bitbucket, Azure DevOps services, and so forth. And so this infrastructure is going into some, repo and branch combination, right? And others can come along, take what we did, if they're taking what I did, they're fixing a lot of what I did, right? And you take that, hopefully what you're doing is creating a pull request and then merging it in. Of course, you can also, push to that repo and branch combination. So this VCS repo branch combination then has a relationship with our Terraform Cloud platform, which I'll draw with a big T. And when I say Terraform Cloud, it's our SaaS offering, right, where you consume it as a service. We also have Terraform Enterprise for those who need a self-managed instance that maybe runs air-gapped, for various reasons. So what I'm describing applies to both. So what happens as we create this pull request, as we merge it, or as we push, is this Terraform configuration, this infrastructure that we have codified, is making its way into what we call a workspace in our Terraform Cloud organization via a webhook notification, right? So that webhook comes in, Terraform pulls that configuration. And when you're working with Terraform, it's like other languages where we're going to parameterize our code, right? And we can instantiate that configuration, feed those parameters in via variables or variable sets that indicate how to use that code. Those variables may be Terraform variables, they may be environment variables. Terraform, actually, if you're familiar with our software for secrets management and encryption as a service, if you're familiar with Vault, Terraform actually has Vault baked in. So it'll handle, storing things like your variables, your Terraform configurations, your plans, and we'll talk about that in just a moment, as well as your state files securely. We can mark variables as sensitive. You'll see that in action today, so that things like cloud credentials are protected rather than showing up in plain text. The next thing that Terraform does when that configuration comes in, when those variables are set, is it kicks off a plan, or you can think of as a dry run, which describes what Terraform is going to do before it does it. This allows us to make sure and validate that what it is that we are doing is valid before we do it. That plan can also be fed into the items that follow, including the Snyk integration, as well as our policy checks. So the Snyk integration happens via what we call a run task. And I've drawn it here in this order because of how it makes sense to run the Snyk run task, because we want to feed the plan in, but technically the run task can be configured to run pre-plan, post-plan, or pre-apply. So as we were describing, the benefit here is that before we actually provision any infrastructure, part of our infrastructure provisioning process is making sure that what we're about to do is secure and compliant, right? So we're not trying to remediate after the fact something that went out the door that is not secure, right? And you can configure that integration to specify, the threshold of what is allowed and what is prevented. So in the workshop we do today, we're going to specify that threshold to be medium, meaning that anything that is a medium or higher vulnerability will prevent us from proceeding. Anything that is a low vulnerability will essentially throw a warning, but won't prevent us from proceeding. The next thing that our Terraform run will do is a cost estimation. And this is simply leveraging the cost estimation API from AWS. So, before I stand up, let's say an EC2 instance or an RDS cluster or whatever it is, I'll have information about what that is going to cost per unit of time, what that will cost per month. And I can feed that information into the next step, which is the policy check. So with Terraform Cloud, you can codify your policies just like you're codifying your infrastructure using the Sentinel or OPA policy as code language. And again, the idea is to make sure that what it is that goes out of our provisioning system is secure and compliant. So if all of those things check out, right? If our plan is valid, if our run tasks that are mandatory pass, if our Sentinel policy check passes, or if there's a soft mandatory violation that someone with appropriate authority approves that exception. If all of these things check out, we're allowed to proceed to what it is that we want Terraform ultimately to do, which is to apply our infrastructure and push what it is that we've codified to those fluffy clouds, right? Now, what comes back as a part of this process, what allows us to then iterate on our infrastructure is the state file. And same thing, Terraform stores that securely. You control who has access to state via role-based access control. And typically the approach here is that no one really needs to have access to state other than maybe your core platform team that's responsible for Terraform and your auditors and things like that. But you also have outputs that come out of that process that you have defined that is intended for the consumers of that workspace. Now, if you look at kind of what is the value of what we are doing here, right? Why take this approach? Value comes down to three things, right? One is we want to be able to increase velocity, right? We want to be able to deliver faster. We want to be able to control cost. And I don't mean just with regard to the, leveraging the cost estimation, but our biggest cost is time, right? What is it taking for me to do this? And the third item is risk, right? We want to lower risk. And this is the beautiful thing here, right? That everything that is going to come out of this provisioning process is going to be secure and compliant. I'm not trying to remediate. Did we lose my screen share? Oh no, there we go. It's back. I'm not trying to, remediate an S3 bucket that went out that isn't encrypted or that is public. I'm not trying to, remediate security groups that are too open. I'm making sure that everything that goes out of my provisioning pipeline is secure and compliant according to the Snyk policies that I have configured, according to the Sentinel or APA policies I have configured. So with that, I'll hand it back for the first module. Let me stop sharing my screen.
All right. Thank you, Yash.
Yeah.
Raj and Patrick for all the intros. Like I said, I was going to disappear for a while and come back, and here we are. Let me get my video on so you can see me there. All right. So we've reached the main event. It's my pleasure to kick off the very fun part where we get to use the AWS workshop accounts to start to deploy infrastructure and secure it with Snyk. But first, some housekeeping. please try to make your screen look just like mine. Just trust me, we've done this a few times before. It's a lot easier to go through these kind of activities when you have your windows side by side like this. And then also make sure that the webinar screen is full screen, because I'm going to try to make things big in my windows, but it also helps if you make this webinar full screen, just so everything's bigger. So you can go and read through the intro section. We've got some words here. I'm not going to read them all to you, but Shivam and Yash already did a great job introducing Snyk and HashiCorp. So I'm going to skip over this intro section, but I will show you this diagram. This is part of our workshop content. I went ahead and downloaded it just to pull it up. Before we start racing through and setting things up in AWS, I thought it'd be good to look at this picture, because this is what we're going to be doing today. So we've got a very simple infrastructure on the right side of this diagram that we're going to be deploying. And there's actually a few things missing from this diagram. We're going to be using AWS Cloud 9 as our developer environment. We're going to pull a code repository in there that's going to have some Terraform code in it. And we're going to deploy that Terraform code, resulting in this architecture that we see on the screen. It is just a simple EC2 instance. It's got an elastic IP so that we can access it over the internet. And while it seems simple, there's a lot of things that we need to think about this infrastructure, because these virtual machines that we're deploying, they have network considerations that we need to be making, the data considerations, things like encryption. So we're going to be looking at all of those areas during this event. So again, we're going to be deploying this infrastructure using Terraform. We're of course going to be using Snyk to take a look at any security issues in this infrastructure and use Snyk to help remediate those. And then when we get into module 2, Yash is going to come back and show us how we can leverage the Snyk and Terraform Cloud integration to bring more automation to this process and apply some pretty cool policy guardrails through the Snyk and Terraform Cloud integration. So let's go ahead and get started. So again, please have your screen looking just like this. Let's by now, I hope you've already got free accounts for Terraform Cloud. So your screen should look something like this. You should be logged in. And then similarly on the Snyk side, it should look something like this. Now yours might say ungrouped here, which is fine. That's just how it looks when you're on a free Snyk account. Mine looks a little different because I've got an enterprise account. But as long as it looks similar to this, you're in a good spot. All right, so let's first get logged into our AWS environments just by copying the code. And I might need to do the approval process. No, I don't. That's good, because I just did this yesterday. I think I can skip that step. So we have to go through and agree with the T's and C's and then join the event. So when we're on this screen, the most important thing is really just the AWS console link right over here. So click that and open your AWS console. Now, we're going to have to go through a number of things because this account for this event is almost completely empty. I actually thought it was completely empty, but according to this, it looks like we have a few tiny little things out there. But it's largely an empty account, so we're going to have to deploy a few things just to really set the stage and allow ourselves to deploy infrastructure. So if you're familiar with AWS, I think you'll find this pretty easy. And if you're not familiar with AWS, we'll try to move kind of slow, and you'll definitely learn a few things in the process as we go through the setup. So let's go to the self-guided workshop setup. This is where we're going to be setting up various things in our AWS account. So the first one here, setting up your AWS account, I believe we've all already done this, but once you're in the account, what we need to do is create an IAM user for this workshop. So you can either click this link. It should take you directly to the IAM landing page in AWS, but personally, I like to just use the search function here and search for IAM. That's going to take us to Identity and Access Management. And once you're in IAM, if you click on users, you'll see that there is a default kind of user here. It says access denied. This is not the user that we're going to be leveraging in this workshop. So we're going to create a new one. So let's go ahead and click create user. The username can really be anything. I'm just going to use what's in the guide here and type workshop user. And there's a checkbox here, provide user access to the management console. We don't need that because all we need this user for is to get their AWS access key. We're going to use that access key later on. So we're just creating this user to get an access key to AWS. So we can click next here. And here we have some permissions options. We're going to attach a policy directly. We just want this user to be a full administrator of AWS. So let's attach a policy directly. And near the top of your list, you should have one there that I'm sure many AWS users have used before. It's called administrator access. So go ahead and check that. And that's going to get our user associated with a policy that gives them administrator access. We can add tags as a best practice. We probably should, have a name there, maybe created by, created on, stuff like that. But this is a throwaway account, so we can skip that and just go ahead and create the user. All right, so your screen should look like this. User created successfully. And now let's go ahead and move on to the next page and get an AWS access key for this user. If you haven't done it already, go ahead and open up like a text notepad, whatever application you like, because we're going to have to copy paste a few security tokens and such into that and use those later. So once we've got our user created, we're going to grab their API key by simply clicking on that user and then go to security credentials. You can also just verify that they have admin access here, but go to security credentials and then scroll down. You'll find a section there called access keys, and then click create access key, of course. To create an access key, we have to go through this process. AWS is strongly suggesting not to use AWS access keys and try one of the alternatives, but we do need an access key. So click other and say next. We have a description. It's optional, so just click next, and we just want to create that access key. And once you're on this screen, we're going to need the information here. So go ahead and copy your access key and secret access key to your notepad that you have on your other screen or your main screen. Since you're not sharing, that's fine. But I'm going to keep these things off to the side on my other screen. All right, so check. Looks like we've got our access key and we are done right here. That's not true. I have downloaded my secret key. So let's go ahead and continue. Yeah, I've got my key. All right, so in the next section, we are going to create a workspace. Workspace meaning an area where we can interact with code and CLI tools, and we're going to be using AWS Cloud9 to do that. So we're going to create a new Cloud9 environment. And that is going to be, again, in our AWS console, we can just type Cloud9, cloud number 9. Go ahead into your Cloud9 service here and click Create Environment. Let's give it a name. I'm going to call this, I don't know, Workshop Environment. Description, let's leave that blank. We're going to use a new EC2 instance. For those who don't know, when you're working in Cloud9, it's a cloud IDE. It actually runs on an EC2 instance in your cloud environment. So we can just configure that according to the settings here. It's let's go with T3 small, which is a pretty small instance. We'll go with Amazon Linux, should be fine. Everything else here looks pretty good. and we'll go ahead and create that. Now that's probably going to take, just a couple of minutes to provision because but behind the scenes, we're actually deploying an EC2 instance that this is running on. And while that's deploying, we can actually take a look. So you can type EC2 right here and open that up and verify that if you go to your instances, that you have a Cloud9 environment. So my EC2 instance is already running. And that means that we should be able to open up our Cloud9 environment just by clicking up this button. May not be ready yet, but let's see. Looks like it's close. All right, so we've got our Cloud9 environment here. It's probably very small on your screen, so I'm going to make that bigger for you. Let's zoom in a little. Let's go twice. That should be a little better. There we go. I'm going to close the welcome page. And I think we're all done on this screen. All right, so everybody should have their user created, their Cloud9 environment open. Next, what we're going to do is create an IAM role. We created the user previously because we need that token to access AWS using Terraform. You'll see how we use that later on. And we need to create something a little different in IAM, a role. We're going to create a role with administrator access and then make sure that this Cloud9 instance is using that administrator role. And then that means that any command we type, like Terraform apply, is going to be running as an administrator and able to deploy infrastructure in AWS. Right now, this Cloud9 is not able to do much, but if we give it a more permissive role, it's going to be able to deploy infrastructure like we want to. So let's go back into AWS IAM. So I'll search here again for IAM. And in this time, we're going to create a role. So go to your roles, and make that a little smaller, and create role. And the AWS service is going to be EC2, which is one of the commonly used services. Scroll down here, click next. And just like before, we're going to give this role administrator access so it can have full access to AWS services. And then just basically next, finish along the way. Oh, we do need a role name. So I'll give it, I'll say workshop role is fine. And scroll down and create the role. So if we search in our roles, well, we don't have to. There it is. We have workshop role and should be good. So once we have that role, again, we're going to attach that role. We're going to use that role on our Cloud9 instance so that it can interact with AWS infrastructure. So let's move to the next step. And sorry if I cough. I had a pretty bad cold last week. But let's go ahead and attach this role to our EC2 instance. So what you want to do is search for EC2 like this and click that. I already have it open. Sorry. All right. Sorry, I had a little tickle in my throat. I already have EC2 open in another tab right here. I did not eat peanuts, I promise, but it feels like I did. All right. So again, in EC2, we have our Cloud9 instance running on EC2. So it's running just like a virtual machine. And what we want to do is apply a different role to this machine. So what we do is we select it like this. And then we go up to our actions menu. We want to take an action on that instance. And what we're doing is under security, we want to modify the IAM role that EC2 instance is using. So go ahead and click that. And then, as you can probably guess, we want to change the role from what it is now to the role that we just created. And then once we update that role, we get a message here that it's been successfully replaced, and our Cloud9 environment should now have broader access to AWS. Actually, there's one more thing we need to do until that happens, but let's go ahead and on the next screen and take care of that. So we've updated our Cloud9, and now we need to update our Cloud9 environment just a little bit more. I'm just refreshing my memory here. All right, so this step is very important. In your Cloud9 environment, there is a setting that we need to change. So go back to your Cloud9, which should be open. Go to your cogwheel in the top right. And in the set of options on the left, scroll down a little more than, or where is it? I've got a glare on my screen. Here it is. Near the bottom, there's one called AWS Settings. So click on AWS Settings. And under credentials, it says AWS Managed Temporary Credentials, and it's on by default. What this means is that this Cloud9 instance is using a set of temporary credentials, as it says. And we can actually confirm that if you type the command AWS STS, I think it's simple token service, get-caller identity. This is kind of like the who am I command on AWS. So this is going to return some kind of temporary credential that this instance is using. You can see the ARN there is workshop participant stuff, and we don't want to use that. We want to use the role that we just created. So watch this. If we turn off this setting, this is what we're supposed to do. Turn off that temporary credential. And then if we run this command again, we can verify that our instance is now using the workshop role that we just created. And we know that the workshop role has admin access to AWS. So now everything we do in this command line is being done as an AWS admin. Simple. Everything else that we see on this workshop screen, we can actually skip. It's a good idea to update AWS CLI, but I think it's using a new enough version, and we can confirm that. We could say, AWS, well, we already used the AWS command line. So you just type AWS enter. You see it's already installed. So I'm sure the version is new enough. And this section about creating an EC2 key pair, you can do this on your own time if you want. If you really want to be able to connect like SSH into the EC2 instance that we deploy, then you're going to need a key pair to do that. But it's not required for this workshop. We don't need to log into it. So we're going to skip that section. And I think that's everything for this right here. Our Cloud9 environment is in good shape. And I think we're ready to move on to the next section. All right, so in the next part, we, again, are going to be deploying infrastructure, and we need to make sure that we have the right set of tools installed to do that, which are going to be Terraform and Snyk. Both Snyk and Terraform have CLI or command line interface tools that we'll be interacting with here in our console. So let's just make sure that those are installed and available. So the part with the Terraform CLI, if you scroll down, you see the instructions for how to install it. And this is another one that we could update if we want to, but I think the Terraform CLI is already installed. So we could just jump to the last step, Terraform-help, just to verify if it's there. Oh, Terraform is not installed. Interesting. So let's go ahead and install it then by copy pasting these commands over here. We're going to use yum to download and install Terraform. I'm not going to explain these commands. Just go ahead and copy paste from the left side to the right side. And in the end, we should have the Terraform command line installed on our Cloud9 environment. So if you've done that and you get down to step 4, Terraform help should work just like this. And your screen should look just like mine. All right, so we've got the Terraform CLI installed. We're getting pretty close. Next, we're going to do a little bit of setup in Terraform Cloud. Again, we're going to need an access token here. We're going to store that off to the side. So go ahead and log into your free Terraform account that you should have already, Terraform Cloud rather. That's going to be app.terraform.io. Only takes a second to log in. When you first log in, you can say start from scratch if that's where you are right now. I'm already past that step, but that's what you need to do. And then just create your organization in there as, some of the first things you need to do when you log into Terraform. There is an instruction here to sign up for a 30-day trial. You can do that if you want, but it's actually optional. Everything that we're going to do in this workshop is going to work just fine on free versions of Snyk and Terraform Cloud. But if you're interested in trying any of the enterprise functionality, go ahead and click that off. You can do that right from within Terraform Cloud. But what we really need is, once we're in Terraform, we need to create a workspace, and we're going to need to get a token, a user token, just like we have an AWS user and an AWS token. Same thing in Terraform. We need a Terraform user and token out of a workspace. So let's go ahead and do this. In Terraform, we're going to create a workspace. I'm going to select CLI-driven workflow, just like the instructions. And workspace, let's call it AWS Snyk Hashi Workshop, December 23. And everything else, we can leave it blank and create that. So we should have a new workspace in Terraform Cloud. And then the next step is to go to our user settings and grab a token, an API token, and then we'll save that somewhere safe. So let's go back to Terraform Cloud. And to get your token, it's going to be your user avatar thing right here, and then go to your user settings like this. And then once you're on your user settings, go to tokens and create an API token. So let's go ahead and do that. Description, we'll call it whatever we want. I'll call mine workshop token. Expiration 30 days should be fine, and generate. That's my token. Enjoy. It's going to last for about another couple of hours. And once you have your token, go ahead and just copy paste that to your notepad. Again, we're going to use that later. All right, so moving on. So we've got Terraform installed in Cloud9. We've got our Terraform Cloud token saved. Now we're going to do something very similar for Snyk as well. So in Snyk, you can get logged in using the link that we shared in the chat, or you can use app.snyk.io and log in. Your account should look something like this with nothing in it, or maybe you already imported a project. If you did, that's great. You get bonus points. But going back to the instructions, what we are going to do is, we're going to get an access token from Snyk. Now, to do this, it's almost identical to what we just did in Hashi. We go to our user page down here. And Snyk, it's here on the bottom left, and then go to your account settings. And right there on the top of your account settings page is API token. I'm not going to show you mine because I already have it in my notepad here, and I actually use this in a few places and don't really want to rotate it today. So what you're going to do is just go ahead and click, grab your token, and store that off to the side somewhere. All right. So I'm going to go back to my home page here on both screens. Let me go here. There's our workshop. Okay, ready to rock. All right, moving on. We've got Terraform installed, but we don't have Snyk installed. So let's go ahead and get the Snyk command line installed. That's just going to be a simple copy paste. Just copy and paste the installation command into Cloud9. And once you're done, you can type the word Snyk, enter, and you should have the Snyk command line installed. Should look like that. And in order to use the Snyk command line, we want to authenticate it with our user account and our Snyk organization. So that's going to be a command that looks just like this. Sorry, jumps around a little. It's going to be Snyk space auth space and then your API token. And there's no period at the end. So it looks just like this. And I'm going to go ahead and do that secretly. Because again, I don't want to give away my Snyk token today, but just go ahead and do that step, Snyk auth, and then your Snyk token. And if you did that successfully, it's gonna give you a nice message and say, what is it going to say? Let's see. Your account has been authenticated. Snyk is now ready to be used. So that's what you should see on your screen. I'm going to clear my screen and bring it back over. There we go. And yeah, so now we're, I think, in pretty good shape. We're almost there on the prerequisites. We've got all our tools, permissions, so just about ready to rock. All right, moving on. Another step we want to do in the Terraform Cloud side, just a prerequisite, we're going to come back later and really understand this more, is we're going to create something called a run task. Yash described it earlier. So we're going to go back into our Terraform Cloud account, and then we're going to go into our general settings, not our user settings. And we're going to go into run tasks, and then we'll create one for Snyk. So let me just go ahead and click through. So let me go to my, I think it's the general settings right here. So I think you just click the logo like this to get to your sort of main page here, and then we'll go into settings and then run tasks right here. And your screen should say no run tasks. And of course, we're going to create one. And now you've got a few fields in front of you, and you might be scratching your head saying, oh, what do I put in these fields? That's the next step. All right. So in order to find what to put in here, well, for the first two, it's just a name and a description. We can fill those out using our heads. So we'll just call it like Snyk run task and a description, Snyk run task. And now we have an endpoint URL and an HMAC key. We're going to get those from Snyk. So going back to the instructions, what we're going to do is we're going to go back to our Snyk account, look through the integrations, and we're going to find an integration for Terraform Cloud in the list. We can search for it. And then once we click on that integration tile, we're going to find the two missing values on this screen that we need to copy paste from Snyk into Terraform Cloud. So let's go ahead and do that. So again, over in our Snyk account, click on integrations, and you can scroll down or you can search, but we should find Terraform Cloud in here somewhere. And there it is. It's under continuous integration. And once you're in Terraform Cloud, just like the instructions say, this has the two values that we need to copy paste over into the run task configuration. So endpoint URL, go ahead and put that in. And then HMAC key, copy and paste. And then once you've got that, we can go ahead and create our run task for Snyk. And we get a nice indication there that it was created successfully. Okay, I believe that is all the prerequisites. And we're going to actually start running the workshop. Okay, so everything's in place. We've got a developer IDE in front of us, Amazon Cloud9, I believe AWS Cloud9. we've got our CLIs installed and all the right kind of access rights to move forward. So now what we're going to do is go grab some code and get some code into this Cloud9 environment so we can start interacting with it. So moving on, we're going to clone a code repository. Once again, it's just a copy paste. This is just going to go grab some code off of GitHub and put us right into the directory where that code is. And if that happened really fast, like it did on my screen, you can verify right here. You should have a folder called vulnerable EC2. That's the name of our code repository. And you can go ahead and open some Terraform code in main.tf just to take a look at what we'll be interacting with today. I'm going to zoom in just a little bit more. See if we can make that bigger. Okay. And then another option here that we've written down is if you have an existing Snyk account with more than one organization, which is true in my case, but unlikely to be true in your case unless you're already a Snyk customer, and you want to use a different organization, then set your org ID. I'm going to go ahead and do that because the default organization I have in Snyk is not this one, and I would like to use this one. So I'm going to go to my organization settings here under General, top one, and right here is the organization ID. So I'm going to go ahead and run that command to make sure that my Snyk CLI is using this organization that I wish. Most of you probably don't need to do that, but I'm going to go ahead and do that. So it was, what was the command again? Snyk config set org equal to that. There we go, org updated. Okay. So we've got some code, some Terraform code in our Cloud9 workspace right now. And before we deploy it, it's a very good idea to run Snyk infrastructure as code. Let's take a look at this Terraform and see if there are any security issues. And we're going to use Snyk to do that. So we can copy paste to run this Snyk IAC test command and go ahead and make your terminal a little bigger. We're not going to be changing any Terraform code yet, but let's go ahead and make this bigger to take a look at some of the results that came out of Snyk. So we just used Snyk to scan this Terraform code. It's the infrastructure that we're going to deploy. But again, as a best practice, let's take a look and see if that infrastructure is secure before we deploy it. So if we look at the results here, we see some of the most important information at the bottom, which is there's one file that has issues. And overall, we have 8 issues. 0 critical, 0 high, which is good, so nothing super serious. But we have 3 medium severity issues and 5 low severity. And Snyk is going to sort these with the most serious issues at the bottom so that when you're scrolling up, you see the most important stuff first. So if we look through these issues, what we have, again, are a few mediums. So we see those 3 mediums here in yellow. And then if we keep scrolling up, we see a few low severity issues as well. Now, the focus of this workshop is going to be on resolving these medium severity issues. So as you can see, we have a security group that allows open ingress. A security group is another word for like a firewall, a network firewall on AWS. And open ingress means that a lot of folks can get through that firewall, in short. So Snyk has given us some information about that, a link to the security rule that's failing, so we could actually open this up in another window and get more details about what it means when a security group allows open ingress. We see a path to exactly where in our Terraform code the issue is, and then also some instructions on how to resolve the issue. So we've got 2 issues with security groups, and then we also have a 3rd issue down here about a non-encrypted root block device. Remember that an EC2 instance is just like a computer, and a computer has a disk drive. So when we're talking about a root block device, we're talking about the disk drive that's attached to the EC2 instance, and it is not encrypted. which is not good, because should someone compromise that, they'll be able to read all of the contents of your disk drive. So we're going to really take these issues into account and get them fixed. So let me just refresh my memory on what the next step is here briefly. Yeah, I think we're going to go ahead and deploy this infrastructure. So even with the issues, we know there are issues, but let's go ahead and deploy the infrastructure. So this is going to be fun. We're going to deploy some real infrastructure. And the way we're going to do that is right here. We're going to start with the command terraform init. Sorry for jumping around. Sometimes when I click, it goes straight to the top. But here we go. We're going to type terraform init. This is going to initialize the backend and any kind of Terraform plugins that we're using. We get a nice green message here that it's initialized. Then we're going to run Terraform plan. Plan is a pretty fun command. It doesn't deploy anything, but it gives us a very good detailed view of what is going to get deployed. So scrolling up here, we see a lot of green plus signs that say your AWS environment does not have this infrastructure in it, but all of this is going to be created if you deploy this Terraform file in front of you. So all pretty expected stuff. We're going to be deploying IP addresses, an EC2 instance, network firewall rules, et cetera, et cetera. So finally, we actually deploy some infrastructure, and that's going to be Terraform apply, and then --auto approve. You don't need auto approve, but it's just going to skip the part where it says, are you sure you want to deploy this insecure infrastructure? And in this case, we do. So let's go ahead and deploy it. This is going to take just a couple of minutes to deploy. Not even. What did that take, like 6 seconds? Wow, that was fast. All right, so if you remember that architecture diagram, we should have an EC2 instance out there. So let's go ahead and verify that. And I just remembered I might have made a mistake. Sorry about that. So I have a feeling that if I go to EC2 instances, that I'm not going to see anything there. Let's confirm. So refresh. Yep, I don't see anything. Sorry about that, folks. I made a mistake. So I'm going to, I actually did create infrastructure, but I created it in US East 2, and I'll show you that. So if we go and change our region to US East 2, this is what you all probably did too, if you're following along. There's an instance out there running, but we want to deploy this into the other region that we were using, which was US East 1, I believe. Yep. Now I could change it now. I'm not sure if it really matters that much. It's in a different region, but yeah, let's actually not worry about it for now. I think it's fine. We deployed into the where did we go? US East 2. So go ahead and find your EC2 instance. It's out there in US East 2, most likely. And once your instance is deployed, we want to do some testing just to verify that those issues that Snyk was pointing out earlier are true. Remember, Snyk was complaining and saying that our security groups allow open ingress. So let's see what that means. Now go find your EC2 instance and just go ahead and click on it. Make that a little bigger. And your EC2 instance has a public IP address, which is right here, public IPv4 address. And what we can do actually is if we pull up another terminal, you can do this in Cloud9 or really anywhere you want, but we can try to connect to that EC2 instance that's out there running. And it's just an SSH command. So it's SSH EC2-user at the IP address for your EC2 instance. And if we hit enter, we're just asked to do a verification step here. I'm not going to do it because I actually don't have the SSH key to log in, but this is what we're here to see, is that we deployed an instance. It is on the internet. And the issue that we have is that anybody on the internet is able to access this, this instance that I just deployed. And that's not necessarily a best practice or what we want. Reason why is because any of you can run this exact same command and try to connect to this EC2 instance. You're not going to be able to, but there is such a thing as SSH brute force attempts. And if you are in your company and you're deploying infrastructure and you just leave it open to the public internet like this, you might have your InfoSec team come and knock on your cubicle or send you a Slack message or whatever and say, hey, you know, you've got an EC2 instance that you deployed, and I see that folks or robots on the internet are trying to break into that EC2 instance, and that's not good. You don't want to be on the receiving end of hackers trying to break into your environment. And that's what Snyk was saying, is that the security group allows open ingress. If we go to security here and take a look at our security groups, we can actually see that it's allowing SSH connectivity from anywhere. And that's not ideal. And that's why we're able to attempt to connect to it like this. So let's see if we can do a better job and fix that. And before we do, we can also just verify that there's an application running on there by curl that IP address. So we can do curl http:// and the public IP, which is this right here. And we see hello world. So we've got SSH access, we've got HTTP access. Anywhere in the world can go and access this instance. Sometimes a good thing, but not always. All right. So we have confirmed that those security issues are real. We scanned with Snyk. We've got our infrastructure deployed. Next, we're going to fix those issues. You can skip the step on destroying your infrastructure. Go ahead and just leave it out there right now. But let's go ahead and fix those issues using Snyk. So let's go back to our Cloud9 environment where we have our Terraform code. And let's, what do we want to do next? Let's go ahead and let's run another scan with Snyk just to have that as a frame of reference. It's going to be Snyk IAC test, very simple. So this should give us the same output that we saw before. And remember, we're going to be focusing on these three medium severity issues. So scrolling down, what we want to do is modify our code according to the instructions here on how to remediate. And we've made that pretty easy for you in the workshop. If you simply scroll down in your code base here, you'll see these comments where it says workshop. These are the areas that we're going to modify. It's a good idea to change your region or just make sure you know which region things are being deployed into. But here is one of the security groups for our EC2 instance. And if you take notice, this is the firewall configuration, the security group ingress. This is what allows things in to our instance. And as you can see, we're allowing SSH from anywhere, which is not necessarily a best practice. So what we want to do for this workshop is modify this rule so that only my IP address, only I am allowed into this EC2 instance. Only I'm allowed to access it. Or more realistically, you might want to change that so like your EC2 instance can only be accessed by a VPN connection or whatever makes sense for your network. But you don't want to leave it like this, which means it's open to the world. So to make this narrow and make it so that only I am able to access this EC2 instance, we're going to change that to my IP address. Now, Now is a good time to open up a web browser tab and say, what is my IP address? Or if you're good with a terminal, it really depends on your operating system, but there are ways to get your own IP. If you're on a Mac like me, it's a little trick. It's curl ifconfig.me, and that'll give you your public IP address that you can copy. So go find your IP address and then change the firewall rule here so that it has your IP address /32. If you're not familiar with CIDR blocks, it's kind of like a range of IPs, and /32 means just the one IP address. If you use something like /24, it would be a much larger range of IPs. But go ahead and put your IP /32. That means only allow that one IP address to SSH into that instance. And then we're going to scroll down a little bit more and find another security group there for HTTP traffic on port 80. And just like SSH, it has a similar rule that's allowing all traffic from the internet. So we're going to change that just like before to our own IP address /32 to restrict that firewall to only let one person in, which is yourself. And then finally, we're going to, let me see, we're going to keep scrolling here, and there's one more section that we want to change, because remember, we've got these three issues. We've solved this one and the other one that's related about an open firewall rule. And now we want to take care of this third issue about a non-encrypted block device. So that's going to be all the way at the bottom of our Terraform. You see another workshop section here. And all we want to do is uncomment this, which is like command /, or you could just click backspace a few times. And what this is saying is that, like, when we deploy this EC2 instance and it's got a disk drive attached to it, we want that disk drive to be encrypted so that should someone gain access to that disk drive, they're not going to be able to read the contents. It's going to be all gibberish if that's the case. So let's just verify that we fixed these issues by running Snyk one more time. And before you run Snyk, take note of this little gray bubble and hit save. It's like Command S. I'm sure there's an option to auto save, but it's not on by default. So just make sure you save your changes. And then we'll try running Snyk IAC test once more. And if we did everything right, then what we should see is no more medium security issues. And there we go. We just solved all three of the most serious security issues. So now we only have a few low issues remaining, which we're not going to worry about in this workshop. And we're feeling good and confident that we've fixed these issues. So we're going to go ahead and update the infrastructure that's already out there. And to do that, we're going to run Terraform plan, just like before, to see what's going to change if we deploy the Terraform that we have in front of us. And I love the output here. It's going to, just like before, instead of all plus signs, we see kind of a blend of certain things are going to be added to the environment. Other things are going to be removed. Things like security groups can be updated in place. But if we keep scrolling, yeah, we see certain things like changing your disk drive from non-encrypted to encrypted forces replacement. So it's good to go through this and sort of educate yourself on, like, what can be updated on the fly versus what needs to be really like destroyed and replaced. So certain things do require sort of a forced replacement like this. So once we've reviewed that and we say, okay, I'm confident with these changes that I want to make to my infrastructure, we just go ahead and run the same command as before, Terraform apply -auto approve. Terraform apply auto approve. So this should take just a few seconds to update our infrastructure. Now it says it's destroying, and I actually want to go take a look at that. So we've got an instance that's running right now, and refreshing, we can see that it's being destroyed by Terraform APIs. And a few seconds later, I think we're going to have a new instance to take its place. Let's see. Still shutting down. Give that some more time to run. Yeah, in the world of cloud infrastructure, nothing is instantaneous. It's always fascinating to wrap your head around all the amazing stuff that's going on and the really incredible capability that we have being able to do this kind of stuff.
David, there was a time where when you wanted new infrastructure at a previous company, you would put in a request and then wait about 3 months. So the fact that I can have a new instance stood up in a couple of minutes or refreshed in a couple of minutes is pretty amazing.
Yeah. You're totally right. In a past life, I'll never forget, I was up at probably 2:30 in the morning, with coffee and a bunch of engineers doing things like, picking out golden virtual machines and, trying to get a whole fleet of them put together. And it was a lot more painful than what we can now do with Terraform and AWS. That's for sure.
Yeah, very grateful for AWS.
Right on. So as we can see, our infrastructure is now applied, and we can confirm that if we go back into our AWS account and just refresh. Isn't that cool? So we've got one instance that's terminated. It's going to stay there for a while, but eventually disappear. And we have this other instance that's running. We can actually just go ahead and confirm in the security groups that our changes were made. You can see the source, so that what this says is that only my IP address is allowed to access the SSH port and the HTTP port. And we can actually confirm that real quick. So if I run the same commands, I should still be able to connect. So SSH EC2 user at, what's the address? Under networking, we have a public address right here. So we're still able to attempt to connect over SSH. And just trust me what I say when I say, if you put some random IP address, you're not going to get a message like this. This is a confirmation that, yes, it's out there. It's listening on SSH. And not a whole lot to see, but we can be pretty confident that only my computer is able to access this machine. And then same as before, we can curl just to make sure the website's running. And there it is. Hello, world. All right. So we just went ahead and secured our infrastructure out there running using Snyk. And now let's go ahead and destroy it. Because if we don't, then Patrick and Raj are going to come find me and egg my house for not cleaning up after ourselves. So let's go ahead and Terraform, destroy, auto approve. That's going to tear down our infrastructure. And did I say house? I meant apartment. I'm in New York, so no house here. All right, so Terraform is going to destroy all our infrastructure, and we can confirm that it should already be shutting down by now. There we go. So we're cleaning up after ourselves. And the last step of the first module is to send results to Snyk. This is a very cool feature of Snyk, and I strongly suggest that if you're getting started with Snyk, that you try this out, and you're going to anyway if you're in this workshop. So let's go ahead and run another IAC scan with Snyk, send that up to the Snyk platform, and see why that's useful. So I'm going to go ahead and let this infrastructure destroy. I'm going to give that just a couple more seconds to finish. Should be done any second. I think this one takes about a minute. And just a reminder that since we have these workshop accounts for a few days, if you want to go a little deeper, you can go back to that section about creating an EC2 key pair and go ahead and grab one of those and follow the key pair instructions. And then you can SSH into that instance and start doing stuff inside of a computer running into the cloud. That's really kind of the logical next step if you want to like really deploy and interact with what's out there. Is like actually logging in and doing stuff. So our infrastructure is destroyed. Now we can go ahead and start running additional commands. I see someone making a joke in chat. All right. So again, we're going to scan with Snyk again and send the results up to the Snyk platform. But before we scan with Snyk, we actually want to revert all the good stuff that we did. Unfortunately, we're going to get rid of it and make this Terraform insecure again. So I'm going to run these individually, and I'm just going to type them because I can type fast. So we can git checkout main.tf. That's just going to revert all the changes we made in our file here. And we don't need to run the second command because we didn't make any changes to output. But the third command here is special. This is the same one that we ran before, Snyk IAC test, but it's got the report option at the end. And what this means is it's going to run a infrastructure as code security test, but report means it's going to send like a snapshot, some metadata of the results up into the Snyk platform so that we can take a look at the results in Snyk. So let's go ahead and do that. Snyk IAC test -- report. All right, and we should get a result that looks same as before, but it's got an extra line at the bottom that says your test results are available over here in the Snyk platform. So we could either click this or just go over to Snyk, and what we will find is if you go to your projects view in Snyk, you have a new project right there. It's actually called a target. And if we open it up, it's got a name that's identical to the code repository that we're interacting with. And if we expand it, we see that there are a few infrastructure as code files that are being scanned. We see our two TF files, main and output.tf. Main, just like the scan results in the CLI, it's basically identical. We see 5 low severity issues, 3 mediums. So if we drill down into there, we see a view here in Snyk. Again, that's basically identical to what we found in the command line. So for each of these infrastructure as code issues, Snyk is going to give us a path to where that issue is in the file, an explanation of the issue, an explanation of the impact of that issue, and then, of course, how to resolve that issue. And if we, for some reason, don't believe what Snyk is saying here, or just, kind of want to take our own plan with this issue, we can ignore it and say, this issue is not vulnerable because, I believe something different, or we could temporarily ignore that issue for some time period, or even permanently ignore that. And you can also tap into Snyk's audit log capability. We have APIs and AWS integrations like CloudTrail Lake and Amazon Event Bridge, where you can really sort of listen to what's going on in the Snyk platform, like when people are ignoring issues like this, and then have like notification and response workflows built around that. Again, what we're looking at here is just a different user interface for the same kind of issues that we saw in our CLI scan. And the reason why this reporting is valuable, not just for infrastructure as code, but all the different parts of our application, is because our CI/CD pipelines, let's imagine we're running Snyk inside of a CI/CD pipeline. That might only run, once or a couple of times a day, or maybe it runs once a week or once a month. It's important to get results every time you're shipping out new code. And when you ship those results into the Snyk platform, you get a view like this. And it's important because we want to have these security issues in our reporting capability. And the only way to get that into reports is by making sure that your projects are being monitored by Snyk like this. Again, reporting issues from these command lines and CI/CD pipelines into the Snyk platform gives us reporting and visibility into where we have issues. And it's also important because security is always changing. Some days we find new security issues, we get those loaded into our database, and then all of the projects and targets that are integrated with Snyk will have numbers changing or new issues appearing or going away. New issues come and they go, and that happens on a daily basis. So if you have your projects in Snyk like this, you can have sort of continuous monitoring of security for all the projects that you've integrated. So with that, I think that is the end of my piece in module 1. So we're going to jump into module 2. And Yash, if you're there, it is my pleasure to hand it over to you, sir.
Thank you so much. I am indeed. Let me get my screen share going one more time, and we're going to share, let's see, the entire screen. Please let me know if what I'm sharing is small. I'm going to do the same setup that you had, David, which is share the two windows side by side. So
it looks
safe command plus a couple of times to make everything larger.
The command plus doesn't work on that one. You got to go view zoom in.
Yeah, I think.
Browser zoom, yeah.
Interesting.
It's either you could use either the hamburger menu or the view menu at the top for Chrome.
The hamburger menu or the view menu. Okay, 1 second. View, zoom in. Yep, I see. It's disabled out.
Yep.
I had another environment we had tested in that was stood up earlier in the week, and it just expired. So as we started the workshop, so hopefully we're going to be good. Let's go ahead and jump in. We're going to start off by configuring some things in your Terraform Cloud organization that David walked you through setting up. Let's go ahead and head over to, in your Terraform Cloud organization, head over to settings at the top level. So if you're somewhere else, just click on the name of your organization, which is going to be at the top left in the breadcrumb. And that'll bring you to this menu on the left side called Settings. And then in Settings, we're going to head over to Variable Sets. So when you're setting up, variable values for your Terraform runs, you can set them at the workspace level. You can also create a variable set that allows you to apply those variables to one or more workspaces or projects. Project is just a container level for workspaces that you can help to kind of organize your infrastructure as code in your Terraform Cloud organization. So I already have a variable set created. You're going to click create variable set and create it, but let me kind of take you through that process. I'll open up this one and I'll also click create variable set. So we're going to need to set, depending on what it is you have, either your AWS access key ID environment variable, your AWS secret access key environment variable, and possibly your AWS session token environment variable. in what I generated in this lab, I didn't need to set there was no AWS session token. It was just the first two. So please use according to your environment what you need for that variable set. So let's give this a name. I'll call this workshop. And then I'm going to, we can apply this to all, we can apply this variable set globally to all workspaces, or we can specify, you know, a project or a workspace to which we're going to apply this variable set. So let me say apply globally, and then I'll add the variables, right? So my AWS access key ID, and then of course the value that I get from when I had generated this earlier under the IAM section in my AWS Cloud Console. And I'm just going to put a value here for the purpose of a demonstration, and I'll add another, and I did the wrong thing, so let's go fix it. in case you did this as well, I want this to be an environment variable, not a Terraform variable. And then I'm going to create another environment variable, AWS secret access key, again, environment variable. But here I want to mark it sensitive. So marking a variable sensitive makes it write only. So what that means is that if, according to my RBAC permissions, if I have the ability to set the value for this variable, I'll be able to. But once it's set, I won't be able to see the value. Terraform can use that value for that variable when it does its Terraform run, but it'll never get displayed to me or to anyone else, regardless of my level of access. So I'll end up with these two set. This one is set to apply globally, and I'll just show you the, you know, the one that I have existing. So this one, I have it called AWS Workshop. I'm going to specify the workspace to which it's going to apply once I create the workspace in this case, or I can say, you know, apply globally, and then the values you see for the AWS access key ID and AWS secret access key is marked sensitive, so you can't see the value. One thing I'll mention here, you know, one of the challenges with cloud adoption and the reason, you know, people at various organizations complain about adopting public cloud is explosive cloud spend, right? No way of controlling it. And part of the reason that that happens is there isn't governance, there isn't policy in place to manage cloud cost. You know, we're just saying you can go and provision anything. So someone is standing up too large an instance, maybe for, you know, the workload that they're provisioning. And Terraform Cloud allows you to, you know, kind of manage that. One of the ways of doing that is enforcing everything to go through your Terraform Cloud organization. So rather than anyone going into the Cloud Console and provisioning anything directly, everything is codified through Terraform. Everything goes through your Terraform provisioning platform. So everything that goes out of your organization is secure and compliant per the run tasks and policies that you have defined for your organization, either at the organization level or at a project level or at a workspace level. So what that means is that the cloud credentials that I have as an individual are essentially read-only, right? We can manage these cloud credentials that actually allow us to provision at a central level, and that way we don't have, you know, the sprawl of cloud credentials where different people have possession of them, and we don't know, you know, how they're being secured and all of that. These can be set centrally and made available via these variable sets to two different workspaces in your organization. So we have our variable set. We're going to then attach the Snyk run task that we have configured to our Terraform workspace. So I think there was a step. Well, we'll go ahead and do it. So one of the things we're going to do when we come back here at the workspace level is we're going to create a workspace. We're going to specify a CLI-driven workflow because of how we're working today. But Terraform also supports a version control or a GitOps workflow, where as we were describing before, when you create a pull request, when you merge that pull request, or when you push to the branch and repo combination that is configured for your organization, it triggers a Terraform run. That run is a speculative plan if it's just a pull request, and then when that pull request is merged or when you do a push, it does the full Terraform run. And then we also support an API-driven workflow. So there's an API for Terraform Cloud. So when you have a pipeline that does tasks before and or after your Terraform run. So for example, some people will run Terraform to provision, and then they might run Ansible to configure the infrastructure that they've provisioned further, for the things that need to be done post-provisioning. This workflow makes a lot of sense. But everything, regardless of the workflow that you choose for a given workspace, that Snyk run task that you have configured gets applied regardless if it's been enabled for that workspace. Similarly, the policies that you're enforcing get applied, right? So again, everything that comes out of our Terraform Cloud provisioning platform is secure and compliant. So let's use CLI for our AWS workshop today. If you have different projects, you can put it in that project. We're going to put it in the default project. Go ahead and create our workspace. And then this is the next step it was having us do over here. We're going to attach that Snyk run task to this workspace. So if I go into the workspace settings, I can then go into run tasks. And I'll only have the ability to do this based on my role, right? So if I'm not a privileged user, I'm just a consumer of that workspace. So I'm able to do a run on it, but I can't admin the workspace. Then I can't just come in and willy-nilly enable or disable run tasks, right? If the admin has configured this run task for this workspace, I am bound to adhere to it. So when you're configuring the run tasks, you want to make sure that you're setting two things. One is the run stage. As we talked about before, when you configure a run task, depending on the nature of the run task, it may make sense to configure it to run before the plan, pre-plan, run after the plan or post-plan, and then pre-apply or post-apply, respectively, to run before the apply or after the apply. In our case, for the Snyk run task, we wanted to run after the plan because we want to leverage the plan to determine whether what we're about to do is secure and compliant or not. Right? We wouldn't want it to run post-apply because we don't want to work in a reactive fashion. We want to work in a proactive fashion, right? So it's post-plan that we've configured it to run. And then the enforcement level can be advisory, meaning that it's just going to give you a warning, but it won't prevent you from proceeding, right? We don't want that. We want it to be mandatory, meaning that you must adhere to this, period, no questions asked. So I'll go ahead and click create. Now, as we had mentioned before, and as David had shown you, when we set up the run task at the organization level, we configured it to enforce for all, policies that are at a medium level, right? So what that means is that medium violations that are at a medium or higher level are going to prevent you from proceeding, and warnings that are at a low level, you'll just get a warning, but you won't be prevented from proceeding. So that's been configured. Let's go ahead and go to the next step, which is I'm going to pop back to my AWS Cloud9 CLI, and I want to check out this vulnerable EC2 instance, the TFC branch. So the git stash will just save the work you've done, so that it doesn't go away, but it gets moved out of the way so that we can work with this copy of the branch. Now, what I want to do here is I want to tell my Terraform configuration how to interact with and use the workspace that I've just created. So if I open up my main.tf, I want to put the name of my organization here. So let me pop back to my Terraform Cloud UI, and I can grab that at this breadcrumb right here. It will tell us the name of the organization, which in my case is workshop-2023-1213. So let me go ahead and pop that in. And then let me come back here and also grab the name of my workspace, which I can, if I go back to my workspaces, oh yeah, this is, I'll go ahead and close out of that. I'll go to this one. So here I can grab the name of my workspace, which is AWS Workshop, and then populate that into here. Great. So what this is going to do is it's going to, oops, sorry, this thing popped back up. Or what did I do? There we go. Yeah. So this will tell my local Terraform run for this configuration where, which backend to use. It'll be this workspace in this Terraform Cloud organization. The next thing I can do is set my token. Now I've already done that. There's a couple of ways you can do that. Is you can set the environment variable here. You can also do a Terraform login and provide your user token or your team token, not the organization token. And then that will enable your Terraform CLI to interact with the Terraform Cloud organization or organizations for which that token is authorized. So let me go ahead and go to the next step now. I did hit save. Make sure you save the modification you did. If you have unsaved changes, you'll see this little circle, but then when you save it, that circle goes away. All right, so let's do a Terraform init. Terraform init. And what this is doing, in addition to, as David had mentioned before, grabbing the providers and modules that we need, it's also, setting us up to interact with that Terraform Cloud workspace. And now, when I do my Terraform plan, instead of running locally, where I'm not subject to any rules whatsoever, the run is actually happening in my Terraform Cloud organization. I can click on this URL and go and examine the run. Let's do that. I could also simply go to my Terraform Cloud UI, right? But here's this plan, this run. The plan is queued, so we're just waiting for it to do its thing. There it goes. So just like David showed you before, when you do your plan, Terraform is doing a dry run, and of course, no valid credential sources because I haven't set. Let me go back to my variable set, and I'm going to apply it to this AWS Workshop workspace. And let me go and do my Terraform plan one more time. Well, you can set a variable set to apply globally. That's a pretty broad application for something like a cloud credential. So just my tendency towards least privilege, even though this is the only workspace we have for our exercise today, but my tendency towards least privilege says apply that variable set only where it's needed, not globally within our organization. All right, this time it looks like our plan is proceeding. Now I am getting the output here just like I did before, but let me pop back here. My previous run failed because I didn't have valid cloud credentials to use, but this one also failed. Let's see why it failed. Our plan was valid, right? Our plan says, rather than just seeing, at the CLI, the output, I'm seeing a little bit of structured output here in the Terraform Cloud UI. So I can see that we're going to build out an AWS instance. It's called EC2 based on how we named it in our Terraform configuration. Here's all the parameters for standing up that EC2 instance, what I've set and what will be known after the apply. And then, also these security groups, which are part of what are responsible for, I think, the failure that comes in the post plan, right? So this is everything relating to my plan. Now let's click on the post plan and see what happened. So here's my run task for Snyk, and I see that it failed. And again, I'm getting the structured output, which is really nice. There were 3 medium severity issues found, and the severity threshold I see is set to medium. So I can see more details by clicking over here. This will pop me over to my Snyk console. And here I see, all of the issues that were identified, and they're the way that they were when David ran through it, where we have a security group that is too open. That's again, our other security group, and then the fact that I have a non-encrypted root block device, right? These are all of the medium vulnerabilities that were identified that are preventing me from proceeding. I can also filter over here on the left side, right? So if I just want to see the mediums and highs, I can do that. There were no high vulnerabilities. If I want to look at just the lows, I can do that also. So let's pop back to our cloud console, and we're going to go and address the issues that we found. Actually, it's gonna ask us to do an apply. Let's go ahead and do that. So let's say we decided, oh yeah, this is nice. I know this errored out, but let's say I hadn't done a plan, right? Let's say I was just going to go ahead and do a Terraform apply. This is the beautiful thing about this integration, is that I'm going to be prevented from proceeding. So I'll get the same errors that I got before. Let me pop back to my Terraform Cloud console. I see, we're doing another run. I won't break it out, but we're doing another plan. Plan looks good. The plan is valid. If the plan wasn't valid, I couldn't go any further. But then my post plan fails again for the same reason, right? So the beautiful thing with this integration is that we are prevented from shooting ourselves in the foot. We're prevented from shooting our organization in the foot, right? It's if what we have codified is non-compliant, we will be prevented from proceeding. So let's go fix the issues, and we'll start with the security groups, right? The ingress. Now we can cheat. We can look for all the spots where we have the issues by looking for #workshop in our code. So let's do that. So here's the, and I'll go ahead and address this, that we want to use US East 1. And then here's my entirely too broad SSH access, right? So I can pull my IP, but I'm just gonna, I'm gonna pretend I'm, let's see, 192, 245, 235. This is a class C block that I had at a company that I worked at back in the day. So that's one. And then let's say for port 80. Now port 80 is something realistically that you might open up to the public internet, more likely 443, 80 for the purposes of the redirect, but 443 is HTTPS and 80 is HTTP, right? So, but let's address this anyway. 192, 168, or sorry, 245, 235.0/24. And then one more, which is the root block device, right? Let's go ahead and by the way, let's say that I was really bad in terms of how I did this, how things are indented. The nice thing you can do is do a Terraform FMT. This is a good practice before you commit any code, by the way, and also a Terraform validate. What that's doing is making sure that our Terraform code is valid, and because of a syntax error or some such thing, that it's not going to error out. These are good things to do before you do a plan or before you commit your code. So we've addressed the issues that were identified. Let's go ahead and do a Terraform run, and we're not going to bother doing a plan. I mean, certainly you could, it's not bad practice, but let's go ahead and do our Terraform apply with the auto approve flag. And what that does is it won't prompt us to say, okay, go ahead and actually provision this. So same thing, I'll pop back to my Terraform Cloud console, click on runs. Let's check out the latest run, see what it's doing. By the way, the other things that would happen kind of after the post plan, which passes time, and the apply would be the cost estimation if we enable that for our organization, as well as the any policies, whether they're Sentinel policies or APA policies that are being enforced for this workspace. So our post plan passed this time. I can come in here and look at the details one more time. And I'll see for this, no medium vulnerabilities, no high vulnerabilities this time, which is great. Just the 5 low vulnerabilities, which aren't going to prevent us from proceeding. And our apply finished, right? So we ended up with these instances being stood up. Of course, with the way that I set the ingress rule, I'm not going to be allowed access to this IP. But let's, I'll show you one more thing before we do the destroy, which is how you enable cost estimation. So if I come back to at my organization level and then go into settings and then go to cost estimation, this is disabled by default, but I can enable it. It's now enabled. Come back up here. And I'm going to do, so you can do the Terraform destroy from the CLI, certainly. I can also go into the settings for the workspace, go into destruction and deletion, and say queue a destroy run. It will prompt me for the name of the workspace, which I can copy paste, and that'll queue the destroy, which will clean up what we did. So I'll just let that run, and I hope you. I'll hand it back. I'll let the destroy finish just so that we can see it. But I hope you found this helpful. I hope this will help you to build things more securely within your organization. So again, our plan, right? We're going to destroy the 3 things that were created here. Our post plan passes. Our cost estimation, you can see that as a result of what we're about to do, we're going to reduce our monthly spend by 4 and 27. Of course, in the initial provisioning, if I had the cost estimation enabled, you would have seen an increase of 4 to 27. And you can take this cost estimation data and feed it into a Sentinel policy that restricts, based on maybe the naming. Let's say we follow, a naming convention for our workspaces, and we say that for dev workspaces your monthly spend can be up to $200. For staging or QA it can be up to $500, and for production it can be up to $1,000. I'm just making up numbers, right? And then you can say that anything that's over that amount results in a soft mandatory violation, and someone with appropriate privileges can override that exception. Or if they don't, then you're going to be prevented from actually provisioning that infrastructure. The nice thing is that all of that history is also part of the audit trail for your organization. So if an auditor comes in, internal auditor or external auditors, and says, show me what policies are being enforced, you can share that. If they say, show me, what policy exceptions have been made, you can also show that because it's part of your provisioning history for your organization. So our destroy is running right now. I had to confirm it because there was no auto approve, right? But that's Terraform Cloud and Snyk working together via this run task integration to allow you to have all of your infrastructure be secure and compliant. With that, let me hand my share back.
That was awesome. Thanks so much, Yash, and for bringing in the cost element. That was pretty cool to see.
Yeah.
So I think that's all that we have. So if folks, speakers want to come back on for some closing thoughts, I want to give a big shout out to the AWS team. Thank you so much for the workshop studio accounts and allowing all of us to go through this fun exercise that we did today. Really appreciate that, seriously. And thanks to all the attendees for joining. Hope you had a good time, learned a few things. And again, you get to keep this for the next couple of days. So have some fun, but be mindful of the resources that you're deploying. And make sure you use that cost estimation feature because you keep it under $4.
There you go.
Thanks a lot, David. And thanks everyone for joining. So as mentioned earlier, you have access to these accounts for 72 hours. So if you're done with Snyk and Terraform labs, right, you still have time to go and learn something new in AWS. And please be mindful of what resources you're spending because these are real production accounts and there's a cost incurred directly to AWS on this one. So please be mindful on this and try to learn something new and get something out of this webinar. Patrick, you want to say something?
Yeah, I think it was a great session. I hope you all learned something. And as you mentioned, Raj, these are not sandbox accounts. These are actual, legitimate accounts. So we do want to make sure that you all are frugal and mindful so we can continue to provide you these type of, this access, as well as another thing I didn't mention before was the survey for us to continue to have these experiences and how we can continuously improve. We would love to get your feedback on how we can do a better job or what we're doing good at, and you want to continue to see us moving forward. So that's all for me and AWS, and we definitely appreciate Snyk as well as Terraform, for these great opportunities for you guys to get on hands-on keyboard and start experimenting. So yeah, thank you.
So Cody, anything?
Well, if we're ready to close it down, Raj.
Okay. Thank you very much, guys. It was great having you all here today.
Thank you so much.
Thanks, everyone.
Thanks. Bye.
Bye.
Awesome. Thank you, everyone, for delivering this workshop to us. I know a lot of work goes into putting together the workshops and then knowing the product in and out. So thank you so much for all the expertise you guys have brought to the table today.
Thank you. Bye.
Thanks. Bye-bye.
So before I dismiss our audience, just a couple of final reminders. Today's session was recorded, and you will be receiving that recording via email here shortly. You can also find the recording on the Security Boulevard website at securityboulevard.com/webinars, and it will be in the on-demand section. I'll be reaching out to two of our most engaged attendees to distribute two $50 Amazon gift cards. So thank you so much for your questions, your chats, and of course for filling out our surveys. I'd like to thank AWS and Snyk for sponsoring our program. And thank you so much, everyone, for following along and participating. We hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect.
Thanks a lot.